Namaskar. In today's lecture for microwave electronics, under the chapter of microwave propagation in Faraday, we will discuss the construction and working of ferrite isolator. In our previous lectures, we have discussed the Faraday rotation effect and its application to the gyrator. So today we discuss the ferrite isolator. So it is defined as a two-port device that has unattenuated transmission in one direction, that is from port 1 to port 2, but provides very high attenuation for the transmission in the reverse direction. Ferrite isolator is used to couple microwave signal from the generator towards the load, and the generator sees a matched load, and the effects such as power output variation and change in frequency, that is frequency pulling, with the variation in the load impedance may be avoided. So this is an important device to be used in microwave benches between the generator and the load. Isolator may be designed in two ways. Number one, rotation isolator, and second one is called the resonance isolator. So first we discuss the rotation isolator. So it is similar to the construction of gyrator. So it is also a two-port device. The input and output ports are rectangular waveguides, and in the middle there is a circular or cylindrical waveguide. The input rectangular waveguide is connected to the circular waveguide with a 45-degree twist section, and the input and the output ports are oriented in the same planes. In the middle of the circular waveguide, a ferrite rod is placed, which is magnetized by the static magnetic field B0, and the length of the rod is taken so as to produce a 45-degree of Faraday rotation. The ends of the ferrite rod are tapered so as to reduce the possibility of the direct reflections from the edges of the ferrite slab. In both the input and the output rectangular waveguides, two resistive pads are being placed, and we will discuss the importance of these two resistive pads. Now we will discuss the transmission of the wave from the port 1 to port 2. So this is the direction of electric field vector at the input port number 1. When it passes through the 45-degree twist section, then the plane of polarization of the wave will be rotated in counterclockwise direction by 45 degree, and a further 45 degree of rotation caused by the Faraday rotation will be produced when the wave passes from the ferrite rod section. So it means that the total phase shift will be 0, since the Faraday rotation is in a direction to cancel the earlier 45-degree rotation caused by the twist section. So there will be effectively no change in the plane of polarization when this wave emerges from port 2, and since it has the correct polarity for its transmission from port 2, so a perfect transmission from port 1 to port 2 can be achieved. Now if the wave is reversed, that is back from port 2 to port 1. So this is being shown in the second polarization diagram. So when this wave is reversed from port 2 to port 1, then since the Faraday rotation effect is a non-reciprocal one, it means the plane of polarization will continue to rotate by 45 degree in the same direction, that is in the clockwise direction. And when this wave passes through the twist section, then the next 45 degree rotation will also be in the clockwise direction. So the total change in the plane of polarization with respect to the input port, that is at port number 2, and will be 90 degree at now port number 1. And since this wave does not have the correct polarity to transmit from port number 1, so therefore this wave will be reflected back from port 1 towards port 2 in the same orientational plane, and therefore also does not transmit from port number 2. So in this way there will be multiple reflections within the isolator. So to absorb these multiple reflections, we will put two resistive pads both in the input and the output guide in the plane in which this electric field vector lies. So these pads will absorb these reflections which were undesirable. So in this way the wave from port 2 to port 1 will be absorbed, and there will be no transmission in the reverse direction. Hence this device possesses the property of a isolator. It is also a uniline device, means it provides a unidirectional propagation from port number 1 to port 2, and there will be no transmission from port 2 to port 1. Now we will discuss the second type of isolator, which is called resonance isolator. So it is a compact device as compared to the rotation isolator. So this resonance isolator is widely used in laboratories. So the working of this resonance isolator can be expressed by the use of the curves of attenuation constant alpha and phase constant beta with respect to the frequency. In the figure, omega 0 is the ferrite resonance frequency or the Larmor frequency. Omega 0 equal to gamma B0. So from this figure we can see that at omega equal to omega 0, that is at when the frequency of wave propagation is equal to ferrite resonance frequency, then the attenuation constant for the left or negatively circularly polarized wave is very small, while the attenuation constant alpha plus for the positively or right circularly polarized wave is very high, and this is shown by a large peak in the curve. So this property of alpha plus and alpha minus will be utilized in the construction and designing of the resonance isolator. So now we will explain this in the construction. So in the construction we will use a left circularly polarized for the one direction in which the transmission or propagation is required, and in the reverse direction the wave should be right or positively circularly polarized, and which has larger value of alpha plus and will be absorbed. So now we will write down the fields in the dominant T10 mode in rectangular waveguides. So these fields are shown in equation number 1. So it can be seen from the hx and hz expressions due to the sign of this j sign, means these two last fields have 90 degree of phase shift, means that hx and hz differ in phase by 90 degree, and when if we take the modulus of hx and hz to be same, then the circular polarization occurs. We will also show that the circular polarization is the inherent property of the wave for dominant T10 mode in rectangular waveguides. Now suppose we take the value of x equal to x1, at which these two fields hx and hz has the same modulus. Then from equation 1, the value of tangent pi x1 upon a comes out to be plus minus pi upon beta a, and if we put the value of beta to be 2 pi upon lambda g, then this comes out to be plus minus lambda g upon 2a. Now we know that for the range between x1 greater than 0 and less than a by 2, the tangent pi x1 upon a will be positive, and if this value is being used in the equation number 1 to find out the ratio of hx to hz, then this comes out to be minus plus j, shown in equation number 3. And also if we take the value of x1 in the range that is x1 greater than a by 2 and less than a, then the value of tangent pi x upon a will be negative, and if we use this negative value of the tangent in equation number 1 to find out the ratio of hx to hz, then it comes out to be plus minus j, shown by equation number 4 with respect to y-axis. Now the solution in equation number 3 corresponds to a negatively circularly polarized field for propagation in the plus z direction, and negatively and positively circularly polarized wave for the propagation in the minus z direction. If the solution given by equation 4 is considered, then the conditions for the polarization will be reversed. So this condition for circular polarization is an thus inherent property of the dominant TE10 mode at two different positions within the rectangular waveguide. That is for one case when the value of tangent is positive, and the another case for which the value of the tangent is negative. So this result will be used in the construction now. So in the figure, a rectangular waveguide is shown with its wider dimension A and lower dimension B. Now if one or two ferrite slabs, the ferrite slabs are shown here, these are being placed in the xz plane. This is the z direction at a location where the field is circularly polarized, that is between 0 and a by 2. This is the value is a by 2. So if one or two such ferrite slabs are being placed and it is being magnetized by a static magnetic field B0 along y-axis, then corresponding to equation 3 and 4 for the one direction in which the wave is negatively circularly polarized, there will be very small or little attenuation due to small value of alpha minus as shown in the curves, and in the reverse direction, since the wave is positively circularly polarized which has very large value of attenuation constant, that is alpha plus, so Due to large value of alpha plus in the reverse direction, the wave is rapidly attenuated. So there will be a only unidirectional propagation. So it is a very important device and is used in all microwave devices, and by using this ferrite isolator, the generator sees a matched load, means there will be no wave from load towards the generator, and generator sees that all the entire power generated by the generator is delivered and absorbed by the load. Now in our next lecture we will discuss another application of Faraday rotation effect, namely the circulator. Thank you.